Okay, we are going to talk about comparing and ordering decimals and whole numbers. Today we're going to worry about the comparing part. We're not going to quite get to the ordering. Comparing is when you have usually two numbers, and you're either going to less than, greater than, or equal to, right? So put that little line on the comparing kind of off to the side and say when I am comparing numbers, usually I have two numbers. Sometimes I can do more because you can do a string, but usually I have two numbers and I am deciding are they less than, greater than, or equal to each other. Okay. And ordering is usually three or more numbers, and you're either putting them in order from least to greatest or greatest to least. You know what the number one mistake there is put them in the wrong direction because they didn't look at the directions well enough or they forgot about it. Okay, that's the number one mistake. So anytime you're asked to put things in order, like check the directions like 5 times, okay, to make sure you did it right. Because there's, that's like one of those mistakes that, if you did it right, just the wrong direction, you could obviously recopy it the other way and get it right. So we definitely want to pay attention to those directions. That is one of the biggest mistakes. Okay. If I were to ask you to use a model to show which fraction is bigger, did everybody get that? Which fraction is bigger than the other or smaller than the other? When I say using models, it's some sort of picture, usually, right? Every once in a while you'll see use a model, use a whatever. What I mean today, if we look at this remember box, we are remembering that decimals are related to fractions. So right in this box here, put that away. This one works out just fine. Decimals are related to fractions. They're really the same thing. They're just written differently. Now I made this a long time ago before I really was good at this program, and I don't know why I always forget to go back and fix it. But if we're working with 4/10, it's the same thing as the fraction 4/10. If you could fill in that bar, that would be great. That was way before I knew how to do that. And on the other side, we're working with 36 hundredths, which is the same as 36 hundredths. Okay? So again, fill in that fraction bar. If I asked you to make a model to prove which one was bigger or smaller, you would make two identical size as much as possible boxes, holes, the whole box. Okay? And then you would break them into the right number of sections, first of all. If I'm dealing with tenths, my box has 10 sections, right? So let's shade in 4/10. So it doesn't need to be perfect, but shade in the first 4 going up and down so that I can tell that all 4 are shaded. It doesn't need to be perfect, it just needs to be shaded. Remember, notes aren't perfection, they are as quick as you can, get all the information you can, and you can read it and understand it later. Okay? Except quickly. Make sure you only got 4. Make sure you didn't go in over past 4. So we've made 4/10, or the fraction 4/10, or we've colored in 4 out of 10 on that side. Right? So we've represented the decimal 4/10. Trust me, you won't have to do this very often, but you do need to know what this means. All right, now we're going to do 36 hundredths. So I'm going to break my box into 100 pieces this time. And how many of them are we going to shade? 36 of them. So let's do the first 3 columns. That's 10, 20, 30. notice I'm keeping the same spot as I did on the one on the left. It's easier to compare if they're in the same place. Again, it doesn't need to be perfect. And then you're going to do 6. I usually come from the top down. 4, 5, 6. I'm going to do 6 on that 4th column. So I have represented 36 hundredths, or 36 hundredths, or 36 out of 100 colored in. They're all the same thing. And actually, we could even do other things with these. These are even numbers. We could reduce fractions and all of that. But we're working with 10 and 100 because those are the ones that go with decimals. That's why we're using the denominator of 10. Those of you that know, like I know you guys touched a little on reducing fractions last year, that you could divide that both by 2 and get 2/5. But, yeah, good. But we're dealing with the 10 because we're talking decimals and we need tenths. So that's why we're not using that in simplest form. Same with the 36. We could divide that by 4 and have 9/25. However, we're dealing with decimals, and we need the 100 to make it hundredths. So now, we can look at our 2 squares, and we can say, well, which one has more shaded? This has 4 complete columns. This only has 3 complete columns and a partial. So, the one on the left has more shaded, right? So that's the bigger number, the greater number in value. By the way, we are 5th graders now. We don't make alligator mouths. I know. Yep. You are welcome to think it, but I don't want to see it. All right? None of these. Yes, I know it's fun. But no more. Yep. Yeah, no Pac-Mans either. You guys are 5th graders. Time to grow up a little bit. You are welcome to think it. I even still think alligator mouth sometimes, but I don't want to see it.
You just thought it.
I did. So, now you guys are going to say, but Mrs. Corin, 4/10 and 36 hundredths, that 36 is the bigger number. No, it's the longer number, but its value isn't as big, right? We have to look at each place. Okay, just because it's longer doesn't make it bigger. Hang on. It's just like alphabetizing, ABC order. If you guys had the word apple, and the word and the word amazing, they're all different lengths. Do we look at the length when we put them in ABC order? No, we start at that first place and we judge, can I make a judgment on the A? No. So I go to the next place and then I can make the judgments. It's the same with a decimal. Okay, we don't care how long they are. We do the places. We start in the same place. The first one that they share here is the ones place, but look, they both have zeros, so it's like they both have A's. So then we go to the next one. And we can make that decision now because this one has 4/10, but that one only has 3/10. It's like having 4 dimes. All right? Just because the number's longer doesn't make it bigger. You could also annex, right? We've talked about how that doesn't change its value. Now think about it. 40, 36. Definitely 40 is bigger than 36. So if that helps you think about it, that's fine too. All right? Sure, you could. It doesn't matter. Then you got 360, but it's still, this one's still bigger because that would be 400. Okay? Yeah, it doesn't matter. It doesn't matter. You have to look at that place. Always. Okay? All right. On the opposite side of the paper, whoops, okay, I added that page. You have a place value chart. Yes, sir. Yep, that's where I'm headed, is making sure that you put them up and down. This is one way of putting them up and down if you had a place value chart. If I was having you compare 1 and 45 hundredths, and 1 and 6, 7, 8, I don't know. And I asked you to use a place value chart. Notice they have the decimals. What I always do when I'm copying things with decimals, you with me, Regina? Is I always start with my decimal. And I work on both sides of it. And then I fill in the blanks. Okay? That is a very, because I know that those decimals have to be lined up. And then I know that these places have to be lined up. So I always start with my decimal, then I do the numbers on each side, and then I fill in the blanks. Okay? I know that kind of goes against the way you're used to writing, but that's a great way to line them up. All right? So if I wrote them on the place value chart, which you guys did here, basically you can compare, starting with the first place they share, and then the next place, and so on and so on. If you feel the need to annex a 0 here to make you feel better, that's fine. That's fine. You are going to have to do that when we add and subtract anyway. Not multiplication, but adding and subtracting, if that makes you feel better. Okay, so on the place value chart, they kind of would like you to convert the decimals to the same place by annexing zeros, which is what I did, and then compare. Going from left to right, compare each place. Now if I have a 2 here and nothing here, what's implied in there? A 0. So I would start right here. Oh, that's bigger. Done. Right? Which 21 is bigger than 1, so you know that. Okay, be careful. Sometimes, see this star here, if the whole numbers are different, then compare at the whole numbers. If it's 15.6 and 17.6, don't look at the 0.6 yet. Look at the font. That happens a lot. Kids will jump immediately to the decimal and forget to look at the whole number. That's an easy one. You know 15 is smaller than 17. Done. Don't worry about the decimals. Pay attention, okay? They'll be in there. Trust me. All right, next page. We're going to do just these 2. Okay, next page. So I want you to copy these into the chart. This is essentially the same thing as recopying them lined up. It's just you're using a chart. You could definitely come over here and line them up. As long as you are lining the place values up. Very important. And then we just start checking. The first one they share. Can I make a judgment on the 3? No. Can I make a judgment on the 4? No. Can I make a judgment on the 2? No. So I have to look here in the hundredths column. Now I can make a judgment. 3 hundredths is bigger than 2 hundredths. So we have to go all the way down to the hundredths. There's a very small difference between these two numbers. Think about if this were money. First of all, if this were money, we wouldn't have those last two. It'd be 22 cents and 23 cents. That's a very small difference, right? But they're still different. 23 still is more than 22. So why is that one bigger? Because 2 hundredths, which is this, is smaller than 3 hundredths. Right? Look at the one in the bottom. Again, kids would immediately say, oh, the 706 is bigger. Is it bigger? No, it's longer, but that doesn't make it bigger. You have to start at the places, which is what makes these charts very handy, because they just help you line them up. Basically, nope, yup, the 8 is bigger. Or you could annex those zeros and think about it. Is 800 bigger than 706? Absolutely. Okay? Don't let that fool you. Don't be quick about it. If you need to come over and write it, if you need, you could even do this. You can bring one of them to the other side and line them up. I don't care. I don't care. I just want to see you doing something like that because this is one of those places where kids make such careless errors and it drives me crazy. Okay? Take that extra second to recopy. Or sometimes what I do is I go, okay, these are both the ones place and they're the same. So let me check here. The tens place. If you can keep track of that. Some of you have a little hard time going back and forth like that and you're better off rewriting them. Alright? Okay. Close these up, put the boards in front of you. You can just slide it in your desk or out of the way right now. Don't worry about putting it away till bell time. Put the boards in front of you. We're going to do a couple of practice problems. You are comparing. You're either going to do less than. What? Okay. Okay, but you need to be careful, that's all. Just need to be careful. Move up a little bit. Okay? Just be careful. Less than, greater than, or equal to is what you're choosing to put in these spaces, okay? So that's what we're doing. We're comparing. We're deciding less than, greater than, or equal to. Number 1. I'm going to do 2 at a time. Okay, 2 at a time. 8 and 675 thousandths. Is it less than, greater than, or equal to 8 and 775 thousandths? And 4 and 8 tenths, less than, greater than, or equal to 4 and 6. Put them both on your paper. Put them both on. Write them all the way down, too. Don't just throw the signs in. Okay, hang on. I'm going to give everybody a minute to just get caught up, okay? And I know these are kind of simple. It's a good way to just refresh our memory. Obviously, a lot of you are remembering that you've done this before, which is awesome. Yep. Oh, I see Dawson's using the place value chart strategy. That's great. Whatever you need to do. You know what else you guys can do? I always forget to tell you guys that. Take a piece of notebook paper. Turn it this way. Look at it. You got columns. Automatic columns. Stick your decimal point on one of those lines and line them up. Use it. I don't care. Some of you, your handwriting is a little bit off. And you crossed out on each side. Yep. Just find a strategy that works for you and use it. That's most important. If it's just bringing one of these over and copying it underneath. No. It's doing, well, sort of. It's recording me and my voice and what I write. Hopefully. Because Joel's been out so long, but I'm trying to, if I do it right, I can send it to him and he can watch it. I'm trying to do more of that, so if you guys are absent, you could watch it and fill in your notes and stuff. It takes time though, so I don't always do it. Let's see. 8s are the same, but look, right there. My 7 is greater than my 6. So that whole, which means that side is bigger, which means that this is 8 and 675 thousandths is less than 8 and 775 thousandths. Right? Okay? And this one here, even though this one's shorter, it's bigger, right? Because 8 tenths is bigger than 6 tenths. Or you can think of it as 800 being bigger than 654. All right, I'm going to have you do one more. Actually, I'm going to have you do 2 more. And number 4. There. 2 more. See if I trick anybody.
Nope.
I hope not. Make sure, again, paying attention. Okay, these are two places that you could get tricked very easily. If you are in a rush. Dawson, do you really need to do that for that one? Do you?
Almost.
I mean, you can, but do you need to? Okay? Couple of things. Always check your whole numbers first. 15 smaller than 19, right? Do I need to worry about my decimals at all? Not a bit. And I kind of did that on purpose so I would know if you looked at the decimal, I would know because it would be the opposite direction. How about this one? They're equal. I can annex that 0, or I can cross that one off. Either way, they are equal. Okay, you guys have about 3 minutes to draw pictures. When my phone goes off, you need to quickly put your stuff away and start packing up.